decreasing. Let's do another one. The graph of a function f of x is shown on the right. Here is the graph of a function. Draw the graph of f prime of x using the same axis. First of all, look for maximum or minimum points, because if the function has a maximum point, at that point the derivative is 0. So we will say, well, this is where I'm going to draw the derivative graph. Alright, let's start by saying f prime of negative 2 equal to 0. What does that mean? The derivative of the function at x equal to negative 2 is 0. Why is the derivative here 0? Because the tangent line there will be horizontal, the slope will be 0. That means the derivative will be 0. F prime of negative 2 equal to 0, and f prime of 1.5. This is x equal to 1.5, and there is a minimum corresponding to that. The derivative there also is 0. That means the graph of the derivative will cut the x-axis at negative 2 and 1.5. The graph of the derivative will cut the x-axis at negative 2, 0. This is an x-intercept of the derivative graph. Similarly, 1.50 is an x-intercept of the derivative. Yep. Negative 2, 0 is one x-intercept of the derivative graph. 1.50 is another x-intercept of the graph of the derivative. We used one information to mark the x-intercepts. Okay, let's now talk about the remaining behavior. On the interval negative infinity to negative 2, can you tell me how the graph is behaving? The function is increasing and concave down. Increasing and concave down. How will the function, the derivative, behave? On negative infinity to negative 2, the function is increasing and concave down. Therefore, its derivative f prime x in that interval will have a large positive value and then decreases to 0 at x equal to negative 2. That means the derivative will start at a large positive value. It will decrease. The function graph is increasing, means the derivative will be positive above the x-axis, and concave down means it will be decreasing. That means the function graph will come like this. The derivative graph will be positive and decreasing. It will be above the x-axis and decreasing. Alright? On the interval negative 2 to 1.5, look at this, negative 2 to 1.5. Can you tell me what is the behavior of the function there? The function is decreasing. Now, if the function is decreasing on that interval, the derivative will be negative. That means the graph of the derivative will come below the x-axis, you see? So, from negative 2 to 1.5, the graph of the derivative will be below the x-axis because it is negative. F prime x is negative and its graph will appear below the x-axis. Some form, we will figure out the form right now. Now, to figure out the form, let's look at this. On the interval negative 2 to 0, look at this, the function is concave down, isn't it? Negative, the function is concave down all the way up to 0. And then 0 onwards, it is concave up. I want you to understand the concavity. Concave down, and somewhere here is going to change that behavior. It's going to be concave up. That means from negative 2 to 0, it is concave down. Now, concave down means the derivative will decrease. So, up to 0, the derivative graph will decrease. And then 0 to 1.5, the function graph is concave up. That means the derivative will increase. So, the derivative graph will decrease, reaches a minimum at x equal to 0, and then increase to become 0 at x equal to 1.5. I hope you're following my argument. So f prime x starts at 0 at x equal to -2. The derivative is 0 here. It will decrease. It is negative. Decreases to become a minimum at x equal to 0 here, and then increase to x equal to increase to 0 at x equal to 1.5. Look at that. That's the derivative graph behavior. And then when from x equal to 1.5 to infinity, on the interval 1.5 to infinity, the function is increasing. If the function is increasing, the derivative will be positive. The graph will be above the x-axis. And it is concave up, therefore it will be increasing, and that is the graph of the derivative function. Look at the beautiful derivative graph that we obtained. Now that's a very important skill. I would advise you to watch this part of the video couple of times and understand these various concepts. Now this is an exercise taken from Math Gallery, a very good exercise to practice the properties of derivatives. Now the purpose of this little puzzle is that there are many graphs given here. You are supposed to pile all these graphs on the left side so that the function graphs will be on top, the derivative of those will be in the middle, and the derivative of those will be at the bottom. That means if you have this function graph, its derivative graph will be here, and the graph of its derivative will be below that. Alright, now let's look at something that we look for. If you here, the minimum occurs, let's say, at -2.5. That means you would expect the derivative graph of this function to cut the x-axis at -2.5 and at 0.5. So look for the graphs here. Does any graph that will be, this is 2 turning points. The derivative cannot have 2 turning points. The derivative of a function will be 1 degree lower. So you would expect only 1 turning point. So you're expecting a graph of 1 turning point, cuts the x-axis at -2.5 and 0.5, which I think would be this. So try and move it over here. Okay, let's do that. So move that graph over there. And then you need to look at which graph represents its derivative. If you look at this, this has a maximum at x equal to -1. That means its derivative graph will cut the x-axis at x equal to -1. Now, we have one that cutting at x equal to -1. And if you notice, it is concave down. It means the derivative will be decreasing all the way. That means this is probably the right one. So let's pick that and put it there. Okay, now here, this is the derivative of a function you're going to put there. Which function will that be? You can see it has an x-intercept that is at 2, 0. That means the function graph must have a maximum or a minimum at x equal to 2. Now, see if any graph has a maximum. Look at this. This has a maximum at x equal to 2. And this is decreasing, positive up to x equal to 2. That means the function is increasing up to x equal to 2 and thereafter decreasing. Positive up to x equal to 2, negative. That means this is the function that will go there. Are you following the argument I'm using? So let's put that over there. What is the derivative of this? This is a negative slope. That means, well, This is a straight line, which means the derivative will be a constant. Which of the function here represents a constant function and a negative? There you got it. So place that over there. And then we look at this. Now, this is a derivative graph. We must place its function graph here. Look at this. This derivative cuts the x-axis at negative 1.5 and 1.5. Is that right? That means it must have a maximum at 1.5. You see, if you look at this, this has got a maximum at x equal to 1.5 and a minimum at x equal to 1.5. That means the derivative, which is 0 at that point, and the derivative 0 at this point as well. And if you look at this, it is concave down up to here. Concave down means the derivative will be negative. Is that right? Yes. And concave up over there, that means the derivative will be positive. Does it suit it? Let's put it there and see if that will work. And does this then qualify to be that function? Let's argue it out. If this is the function has a minimum at x equal to negative 3, which means its derivative will cut the x-axis at x equal to negative 3. It has a minimum at x equal to 3. Its derivative must cut the x-axis at x equal to 3. There you go. It has a maximum at x equal to 0. That means the derivative of this function must pass through the origin at x equal to 2. Look at that. That means all this, I think, is correct. Let's check it. Oh well, it says all correct. Now what I would like you to do is use this website in Math Gallery, and you can actually do a number of these problems on your own and make sure that you understand the properties of these derivatives fairly well, so that in the next lesson we can use it. As we move on, we will use all these properties. Then you shouldn't be fumbling. You should be confident as we move on. Then you begin to understand and appreciate and really enjoy calculus. Calculus is a very, very beautiful subject which explains a lot of phenomenon around you. So take pride in learning it and enjoy it. All right?